eventually what's going to happen is that stars that aren't very massive will get to a point where they will fuse all of the elements that they're able to. They won't be able to produce enough energy to fuse any other elements, and eventually what it's going to become is what's known as a white dwarf. The life cycle of massive stars, ones that are much larger than our sun, so they'll go through kind of the same beginning where they start as just a cloud of gases, and they will turn into a main sequence star, albeit it'll be larger than ours. Instead of turning into just a red giant, a red supergiant, it'll continue to fuse elements until it gets up to iron. Iron is going to be the largest element that stars are able to fuse, and what's going to happen at that point is that iron takes so much energy to fuse that the star's core is actually going to collapse upon itself, and then it's going to explode outward, ejecting all this matter, where it becomes this thing called a supernova. Eventually what's going to happen with the remnants of the star, depending once again upon its mass, it will either then become a neutron star. Basically, a neutron star occurs when the electrons, the repulsion of the electrons is such that it actually converts all the electrons into neutrons so that it can pack them in there denser together. Or if it's really massive, it can become what is known as a black hole. Okay, the Big Bang Theory suggests the universe was created from a small, hot point that keeps expanding and cooling. One major piece of evidence to support the Big Bang Theory was discovered by Edmund Hubble. Basically what it was, he discovered a Doppler shift in light from distant galaxies. Basically what he was able to do is he was able to measure that due to this Doppler effect, as objects move away from you, the wavelengths are elongated. They shift more to the red, the longer wavelength of visible light. If objects are moving toward you, the wavelengths emitted are going to be compressed. They're going to be much shorter. They're going to appear blue. And what Edwin Hubble observed was that all the galaxies tended to be moving away from the Milky Way. The light emitted was shifted into the red portion of the spectrum. One other piece of evidence that was indicator that there was a Big Bang Theory was that there was background noise in the form of like microwaves, echoes coming back from deep space. Atoms emit light by basically what's occurring here is that you'll notice that we have an electron here at a ground state. It is absorbing energy from some external source, albeit it could be light, it could be heat, it could be high voltage electricity, just some external source of energy striking that electron. And what's going to happen is that that electron is going to jump up in energy levels and go into what is known as an excited state. So originally the electron was here at this low energy state, its ground state, it absorbed energy, it jumped up in energy. And what happens is that that electron wants to return back down to its low energy state, its ground state. As it does that, that energy is released in the form of visible light. An atom is simply the simplest form of an element. It's the smallest, particle that maintains unique properties. An ion is simply nothing more than an atom that has a charge. And then the next two are cations and anions, are the two types of ions. A cation is a positively charged ion. How does it become positive? It loses electrons. An anion is a negative ion. it is formed by the gain of electrons. And then finally, a compound. A compound is simply two or more elements, atoms of different elements, that are chemically combined in a fixed proportion. And so what that means is that they are combined either by gaining, losing, or sharing electrons. And then a compound has a definite formula. It's always, like water is always 2 parts hydrogen to 1 part oxygen. If that ratio is different, it's not water. It's some different substance. Modern periodic law basically refers to the periodic table and how it is set up due to a repeating pattern. So like every 8 elements, you get similar properties. This is largely due to the electrons and their configuration, where they exist, what energy levels, what paths they travel in, the shape of those paths, and their numbers. So really this deals with electron configuration. And then B, what are the 3 classes of elements? Which one is the largest? The periodic table is divided into 3 parts. Everything that is to the left of the stair step is considered to be a metal. And you'll notice that the vast majority of elements are metallic elements. Non-metals are found on the right side of the stair step, and then the metalloids are the ones that are directly in contact. That's like boron and silicon, germanium, arsenic, antimony, tellurium. Those are the metalloids, the ones that are directly in contact with the stair step. Okay, the alkali metals are generally these group 1A elements over here. The alkaline earth metals are group 2. The transition metals are generally these here. Sometimes you'll hear me refer to them as the D block. These are the transitions. The inner transitions are the lanthanide and actinide series, the ones that are here on the bottom. The halogens are group 17 elements, and the noble gases are in group 18. The periods refer to the horizontal row. So this is the first period, second, third, fourth, fifth, sixth, seventh period. Elements in the same family in the periodic table. Families are sometimes referred to also as groups. They're the vertical columns. They all have similar properties due to similar arrangement of valence electrons, the ones in the outermost energy level. Elements that are in a period, which will be the horizontal rows, their properties vary quite a bit. They generally will have valence electrons in the same energy level, but besides that, the number of valence increases as you move from left to right across the table. F, the reason that elements of the family in the periodic table have similar physical and chemical properties is mainly due to, once again, the same number of valence electrons. Okay, and then you were to label on the periodic table the number of valence electrons for the representative elements. So group 1, they have 1. Group 2 has 2. All those transition metals in the middle generally have 2 valence. Some of them have 1. Over to group 13, they have 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7. And group 18 has 8 valence. And so, if you look at this, it's asking to identify the number of valence electrons these atoms have in their neutral state. So calcium, being a member of group 2, has 2 valence. Carbon is a member of group 14, it has 4. Nitrogen is group 15, it has 5. And then bromine, which is in group 17, they have 7 valence. Okay, comparing ions to their atomic size, their radii, here's the thing to remember. I'll just do a couple of quick examples. Lithium, if you look at lithium's electron configuration, it's 1s2, 2s1. That's lithium. Alright, if it loses an electron, which one's it going to lose? Well, it's going to lose this one on the outside. So lithium isn't going to go look for 7 more valence, it's going to give up just one so that it has its octet. It's really a duet, but a lithium-ion electron configuration is 1s2. Obviously, lithium is going to be larger than a lithium cation. So cations are smaller than their parent element. On the flip side, you have anions. So, for example, chlorine. If I do chlorine, it's 1s2, 2s2, 2p6, 3s2, 3p5. Okay? And so if you look at a chloride anion, it's basically the same, except for it's 1s2, 2s2, 2p6, 3s2, 3p6. It has picked up an electron from somewhere. So what's going to happen is that the number of protons within the nucleus remains the same, 17 on both. Chlorine has 17 electrons. Chloride has 18 electrons. The 17 are not going to be able to hold the 18 electrons in as close as it could the 17. Therefore, an anion is slightly larger than its parent element. So, lithium would be the larger. Chloride anion would be larger, and then aluminum. Looking at aluminum, it forms cations because it has 3 valence electrons. It's easier to lose 3 than to go out and look for 5 more. And so therefore aluminum is larger than the aluminum cation. Alright, atomic radius is basically what it sounds like. It is just the radii of an atom. It goes from the nucleus out to the edge of the energy levels where the electrons exist. And so what happens to this trend as you move across a period? Well, you'll notice as you go across a period from left to right, the radius gets smaller. Why? You have a larger centralized positive charge. They're able to hold those valence electrons in a little tighter. What's the trend as you move down a group? So as you move down a group or family, you will notice that the atomic radius gets larger. Why? More energy levels. More energy levels means the radius is larger.